2025 just rewrote the science textbooks, forever changing our perception of reality. We've found a previously hidden organ in every cell of your body, captured truly impossible images from deep space, and created technology that genuinely sounds like pure magic. These aren't just isolated discoveries. They are profound glimpses into the fundamental nature of reality itself. Today, we'll explore 7 groundbreaking breakthroughs that have utterly transformed our understanding of life, the universe, and our place within it. Each one represents decades of unwavering human curiosity, incredible ingenuity, and the relentless pursuit of knowledge. Welcome to 2025, arguably the most extraordinary year in the history of modern science. For over 3 centuries, we've peered into cells through microscopes, believing we cataloged every structure, every organelle that makes life possible. We were profoundly wrong. Our sophisticated tools, for all their power, somehow overlooked a fundamental component. In January 2025, researchers at MIT, using cutting-edge imaging techniques, discovered something extraordinary hiding in plain sight. They called it the hemifusome. Imagine, if you will, that every cell in your body contains a previously unknown compartment. A microscopic factory that's been operating in secret since the dawn of complex life. This elusive structure, perhaps too small or too dynamic to be easily seen before, sits at the very heart of cellular division, orchestrating the precise choreography that allows one cell to become 2. It's not just another organelle. It's a master conductor, meticulously ensuring that when cells divide, each daughter cell receives exactly what it needs to survive and thrive. Without its precise guidance, cellular replication could falter, leading to chaos. The implications are staggering. This groundbreaking discovery could revolutionize our understanding of cancer, aging, and genetic diseases, potentially opening entirely new avenues for treatment and prevention. We've been studying life for centuries, yet life still holds secrets that can fundamentally change everything we thought we knew. The hemifusome reminds us that even in the most familiar territories, profound mysteries await discovery, challenging our assumptions and pushing the boundaries of biological knowledge. In February 2025, the world witnessed the historic first. A spacecraft captured the very first image of the sun's mysterious South Pole. For decades, scientists could only guess what this hidden region looked like, relying on indirect measurements and computer models. But thanks to the Solar Sentinel mission, we now have a direct view, revealing swirling plasma, magnetic storms, and features never before seen by human eyes. This breakthrough will help us understand solar weather, protect satellites, and even predict disruptions to our power grids here on Earth. It's a new era in solar science, and a reminder that even our own star still holds secrets waiting to be discovered. In the realm of computing, we've reached a critical crossroads. Silicon chips, the foundation of our digital age, are rapidly approaching their physical limits, constrained by heat and electron interference. But in April 2025, researchers at Stanford University unveiled a breakthrough that could change everything. Optical chips that process information using light instead of electricity. Think about this for a moment. Light travels at 300 million meters per second, the ultimate speed limit of the universe. Crucially, it generates no heat like electrical current, leading to vastly improved efficiency. It also doesn't suffer from the resistance that slows down traditional processors. These optical chips don't just promise faster computers. They promise a fundamental reimagining of what computation can be, unlocking new paradigms for problem solving. Early prototypes are already processing data at speeds that would have been considered impossible just years ago. But the true revolution lies in what this technology enables. Imagine artificial intelligence systems that can think in real time, processing vast data sets instantly. Climate models that can predict weather patterns with unprecedented accuracy. Medical simulations that could design personalized treatments in minutes rather than months. We're not just making computers faster. We're approaching the speed of thought itself, creating machines that can process information at the fundamental speed limit of the universe. Perhaps no challenge facing humanity is more pressing than our relationship with carbon dioxide. For decades, CO has been a harmful byproduct of industrial civilization threatening our climate. But what if this very gas could become the clean, sustainable fuel that powers our future? In June 2025, a pioneering team at the University of Cambridge achieved something truly remarkable. They created a novel solar reactor pulling carbon dioxide directly from the air, efficiently converting it into valuable liquid fuel. Not just any fuel, but jet fuel, diesel, and gasoline, chemically identical to their fossil counterparts. These drop-in fuels are usable in existing engines and infrastructure, offering a seamless transition. The process is elegantly simple, yet profoundly revolutionary. Solar panels power this innovative reactor. Atmospheric CO combines with water, leveraging artificial photosynthesis to synthesize complex hydrocarbons. It's nature's own incredibly efficient process, refined and accelerated by human ingenuity. This isn't merely carbon capture, it's active carbon transformation. Every liter of fuel produced actively removes CO from the atmosphere while creating vital energy. This truly closed loop, a circular economy for carbon, could fundamentally change our relationship with this element, transforming our greatest environmental challenge into our greatest energy opportunity. The human brain, with its 86 billion neurons and trillions of connections, has long been considered the final frontier of scientific understanding. For centuries, its intricate workings remained largely inscrutable, a profound mystery. But in July 2025, researchers at the University of California achieved something that borders on science fiction, a true marvel. They created an AI system that can decode human thoughts directly from brain activity. Leveraging cutting-edge fMRI technology combined with sophisticated deep learning algorithms, they can now translate the subtle electrical patterns in your brain into coherent words, vivid images, and even complex concepts. Volunteers think about a red apple, and the system instantly displays a red apple. They imagine walking through a dense, sun-dappled forest, and the AI meticulously reconstructs that entire forest in digital form. This isn't mind reading in the mystical sense, not telepathy. It's precise pattern recognition at the most fundamental level of human consciousness, revealing the very architecture of thought. The implications stretch far beyond the laboratory, promising to revolutionize medicine and our understanding of the mind. For people who have lost the ability to speak due to stroke, ALS, or other debilitating diseases, this technology offers a direct, life-changing pathway from thought to communication, restoring their voice. For researchers studying consciousness itself, it provides unprecedented insight into how thoughts form, how memories are encoded, and how emotions flow through the neural networks of the mind. We're not just building better computers. We're forging profound bridges between the biological and digital worlds, opening new chapters in our understanding of what it truly means to think, to feel, to be human. In August 2025, biologists unveiled a plant that glows in the dark. No genetic trickery, just pure bioluminescence. By harnessing genes from deep-sea organisms, researchers created leaves that emit a soft, natural light, illuminating gardens and pathways after sunset. This breakthrough could revolutionize sustainable lighting, reduce energy use, and bring a touch of magic to our cities and homes. It's a living example of how nature's ingenuity can inspire new solutions for a brighter, greener future. Gene editing has always carried a certain violence. For decades, the process involved literally cutting the DNA, removing an unwanted section, then inserting new genetic code. This groundbreaking method was akin to performing surgery with a blunt instrument, often leading to unintended cellular damage and irreversible changes. But in September 2025, researchers at the Broad Institute unveiled CRISPR 3.0. This revolutionary system is so precise and gentle it can edit genes without ever cutting the DNA strand. Traditional CRISPR works like molecular scissors, cutting and pasting genetic code. CRISPR 3.0, however, operates more like a sophisticated word processor. It meticulously changes individual letters in the genetic alphabet, correcting typos or inserting new instructions, all without disrupting surrounding text or causing cellular trauma. No instructions, all without disrupting surrounding text or causing cellular trauma. We approach genetic medicine as just a technical improvement. It's a profound philosophical shift in how we approach genetic medicine. The new system corrects genetic diseases at their source, turning off harmful genes or turning on beneficial ones, all without the significant cellular stress that came with cutting DNA. Early trials have shown remarkable success in treating sickle cell disease, certain forms of blindness, and even some cancers. But perhaps most importantly, CRISPR 3.0 is reversible. If something goes wrong, the edits can be undone, returning the genetic code to its original state. We're entering an era where genetic diseases might become as treatable as bacterial infections, where the code of life itself becomes as editable as a document on your computer. These 7 discoveries represent more than scientific progress. They represent humanity's endless capacity to push beyond the boundaries of known, to find wonder in the microscopic and the cosmic, to transform challenges into opportunities. Subscribe for more Science Explained.